Hello everyone, today we will learn the fillet welding on the T-joint in the flat welding position. In this lesson, you will learn the operational requirements for fillet welding on the T-joint in the flat position, how to develop a welding plan, how to select the welding parameters, how to weld qualified components meeting requirements of welding safety, cleanliness, environment, and the welding process, how to conduct a visual inspection of components according to standards. This is a construction drawing of flat precision welding on a T-joint. We can see from the drawing that the material of the specimen is Q235. It consists of two steel plates, each 300 mm long, 150 mm wide, and 12 mm thick. The assembly angle is 90 degrees. Flat precision welding is conducted on T-joint, cruciform joint, and corner joint placed in a flat position. Its advantage is that it is easy to ensure that uniform size of the welding neck, so it can solve the problems of the collapse of the welding meat and the uneven distribution of the welding necks. The welding process is easy, fast, and productive. However, because of the angle between the two plates, it is difficult to avoid defects like slag including undercut, etc. Therefore, we will use a slanting high current and adjust the electrode angle to promote the separation of molten metal and slag in the welding process. We determine the weld neck size to be 10 mm according to the thickness of the specimen. We need to weld only two layers, the bottom layer and the cover layer. In the following, we will learn the welding method and the process of this project, according to the steps of preparation, assembly, welding of the bottom and cover layers, as well as inspection. Before welding, we must prepare as follows. 1. Safety check. Ensure that protective equipment is worn properly and in good condition. Clean up the work site. There must be no flammable and explosive articles. 2. Welding machine preparation. Check whether welding machine cable, welding bar wire, welding clamp are properly connected and debug. 3. Auxiliary tools preparation. Prepare tools such as grinders, welding hammers, chisels, files, steel brushes, steel rulers, and weld inspection rulers. 4. Specimen preparation. Check the size of specimens according to the drawing. Remove oil, grease, rust, and oxide from within 20 mm on both sides of the parts to be welded until the metallic luster appears. This is specimen after grinding. 5. Welding materials preparation. According to the specimen material, we choose E5015 electrodes, diameter 3.2 mm, 4.0 mm, as they have better processing properties. The rods should be dried at 350 to 400 degrees Celsius. Before welding and keep warm for 1 to 2 hours. Use as needed. The next step is specimen assembly. First, pairing. Put the prepared plates on the assembly platform and draw assembly positioning lines according to the construction drawing. Then follow the lines and assemble the plates into a T shape without any gap between. Tack welds are at the back ends of the fillet welds and are 10 to 50 mm long. Ensure standing plate and base plate insect at a 90 degrees angle. After tack welding, check assembly position, tack weld, verticality, groove place. This is assembled specimen. Now, let's learn how to weld the bottom layer. Choose 3.2 mm diameter electrodes. Set a welding current at 111 to 138. Place the assembled specimen on the platform in a bolt-like position. During welding, hold the electrode at a 75 to 85 degrees angle against the welding direction and at a 45 degrees angle to the specimen plates. In the welding process, we usually move the electrode straight across and hold a short arc length. Move the electrode at a uniform speed and keep the electrode core in the center of weld bead. When moving the electrode, we can adjust the angle between the electrode and the welding direction to promote the separation of molten metal and slag. Remember to always keep the molten pool in an oval shape. This is a schematic diagram of electrode angle when welding the bottom layer. After the bottom layer is completed, clean the weld bead with a steel brush and a welding hammer. This is specimen with the bottom layer completed. The next step is to weld the cover layer. Choose 4.0 mm electrodes and set current at 160 to 180 A. The cover layer usually needs only one bead, and we wave the electrode in a zigzag or crescent motion. The electrode angle is basically the same as that for the bottom layer. Weld at a uniform speed and keep the arc 2 to 4 mm long. Remember to keep the molten pool in an oval shape. Keep a fixed weaving width. Pause momentarily when reaching the weld sites, which ensures good filling of the weld and base metal and avoids undercut. The weld bit is slightly concave after welding. This is specimen with the covering layer completed. The key technique of flat precision welding on a T-joint is to distinguish molten pool and slag. Move the slag to the rear of the molten pool so as to clearly observe the weld and avoid mixture of slag and molten that causes slag inclusion. After practice, we should organize tools and equipment. Turn off the power, clean up the worksite, and write welding records. The surface of the specimen must be cleaned up without traces of processing, grinding, or repairing. Then, inspection of improper filling of weld, slag, surface porosity, crack, the width of weld, equal leaks, undercut, verticality, mechanical damage, or arc abrasion, weld surface formation, etc. should be conducted by welders themselves, field welders, and professionals according to writing standards. Now we have finished the lesson, and I'm sure that you have already got a basic understanding of this welding operation. That's all for today. Thank you.